Okay, my CP guys. Today we're in Unit 4, starting Lesson 6. And we eventually, after we hit the warm up, we're just going to do a warm up at the top. But we're going to be solving equations below that use a new method today. It's called the square root method. We are able to use it when there's an x squared term and a constant, but the b term is missing. So anyway, let's go back to the warm-up. We're going to simplify each square root, and we are not going to use decimals. So in letter A, there's a couple ways of teaching this. One's using a factor tree. The way that I teach it is I want people to think, what is the biggest perfect square that multiplies into 12? Okay? If you can't remember what a perfect square is, remember the examples are 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, and so on. And these numbers that I just said, that when you square root them, they get a whole number as an answer. So what can I break 12 into? Two numbers that multiply to get 12, but one of them is a perfect square. So that would be 4 times 3. We know that the square root of 4 is 2, and the square root of 3 will just drop down. So the square root of 12 simplifies to 2 times the square root of 3. Letter B, square root of 27. What is a perfect square? What's the largest perfect square that can multiply into 27? That would be 9. So 27 can be written as the square root of 9 times the square root of 3. The square root of 9 is 3, and just bring down the square root of 3. So the square root of 27 simplifies to 3 times the square root of 3. 80. Can we think of a perfect square that multiplies into 80? This one's a little tricky. If you want, I would suggest, if you can't do the mental math here, I would suggest busting out a calculator. If you want to pause this now, go ahead and try it out with a calculator. Anyway, 16 is the biggest perfect square, so we write square root of 16 times the square root of 5. The square root of 16 is 4. Bring down the square root of 5. So 4 times the square root of 5. Okay, let's think of the square root of 32. What's the biggest perfect square that multiplies into 32? 16. So square root of 16 times square root of 2. The square root of 16 drops down. Bring down the square root of 2. Okay, don't get alarmed by fractions. They're actually really easy, especially this one. You can actually, when you have a gigantic square root, notice it's covering both the 4 and the 81. That means it's intended for both numbers to be square rooted. So, and both of them are actually perfect squares. So the square root of 4 is 2. The square root of 81 is 9. So no more radical in the problem. Now, it's a little different in letter F. If I were to notice the radicals covering the whole fraction, so that means it can be broken up as square root of 7 divided by the square root of 16. The square root of 7 cannot be simplified, so it just drags over. The square root of 16 can, 4. Square root of 16 over 4. G is very much the same thing as F. This can be rewritten as the square root of 11 divided by the square root of 25 because the radical is covering the entire fraction. The square root of 11 is a prime number. It cannot be simplified, so carry it over. And then the square root of 25 can be simplified to 5. So remember, when you're square rooting something, a number, get rid of the radical. And a letter H, it's actually like the problems above. A little out of order here. Anyway, What's the biggest perfect square that multiplies into 75? That would be 25. It goes in 5 times. So we write it square root of 25. I always write the perfect square in the first one, and then the one that's not a perfect square, I put that in the second. So square root of 25 is 5, and then bring down the square root of 5. All right, so that was a warm-up to get us into the meat and potatoes of our lesson today, which we're going to solve equations by the square root, or using square roots. It's called square root method. Anyway, we cannot use this for every single quadratic in the world. We can only solve it with quadratics that has an x squared term and a constant. It cannot have the bx term in it. If you had the bx term, that means we would have to solve by factoring or other methods. So this is a very specific way of solving. So here's the steps. So you want to pause this and write it down in your packet now. Okay. Now, in example A, I notice the first step I need to get it in the form. We do not want it equal to 0. Setting it equal to 0, that's when you're factoring to solve. In solving by square roots, we want the x squared term by itself. By itself. So what are we doing here? We're adding 36. Our next step is we square root both sides to get rid of the exponent. Okay, it gets rid of the exponent. Now, here's the deal. The square root of 36 we know is 6, but there are going to be 2 answers to all of these problems. When we square root a number, we actually need to throw in a plus and a minus. What this means is we have 2 answers, positive 6 and negative 6. Using this symbol plus minus is just a way to abbreviate 2 numbers. Letter B. Let's get x squared by itself. That must be our first step. So we need to divide both sides by 5. Again, our first step, get x squared by itself. Next, once we have x squared equals a constant, x squared equals c in other words, get rid of the exponent, square root both sides. So the exponent goes away. You take the square root of 16 as 4, and you must throw in a plus minus. So we have 2 answers, 4 and negative 4. Letter C. We need to focus on getting x squared by itself. The first thing I should do here is subtract 5 from 41. Don't square root yet. There's a 3 in front of the x squared. So you need to divide by 3. So x squared equals 12. Now that x squared is by itself, now you can square root both sides. So x equals, now the square root of 12. We want to think of, like back in the warm-up, what 2 numbers, one of them multiply to get 12, and one of them's got to be a perfect square. That would be 4 and 3. So the square root of 4 times the square root of 3, so that would be square root of 4 is 2. Bring down your square root of 3. So that'll be in your answer, and throw in your plus minus. So your 2 answers are 2 root 3 and negative 2 root 3. So next, letter D. What's the first step you need to do? Divide both sides by 6. We need to get x squared by itself. So now that x squared's by itself, Let's square root both sides. Gets rid of that exponent. Think back to the warm-up. Square root of 20. What two numbers get 20? One has got to be a perfect square. 4 and 5. So square root of 4 is 2. Bring down the root 5. And lastly, throw in your plus minus. So your answers are 2 root 5 and negative 2 root 5. All right, we throw a curveball at you now. This is the first problem we have with parentheses. Technically, step 1 is taken care of here. This is in the form, instead of x squared by itself, it's parentheses squared by itself. So step 1 is technically done. What we want to do right away here, when there's nothing around the parentheses squared, we can go right into square rooting. Remember, the purpose of the square rooting is to get rid of the exponent. So what we would just drop down is x minus 1. And then pull the 32 to the side, and what two numbers multiply to get 32? What's the biggest? That's a square root. Now, if you said 4 and 8, yes, 4 is a perfect square, but it's not the biggest that goes into 32. The biggest is actually 16. So it would be square root of 16 times the square root of 2, which would be square root of 16 is 4 root 2. So don't forget, you need to throw in a plus minus. Please get into a habit of that in every problem today. Now, a lot of people stop here and think this problem is done, but I got to ask you, is x by itself? No. So this problem's not done. We have not solved for x yet. We don't know what x is because it says x minus 1. So what do we got to do? It's pretty simple. We have to add 1 to both sides. Now, it's going to look a little funky here. Yeah, we got our x equals, but you cannot add the 1 to the 4 because they are not considered to be like terms. So they are not considered to be like terms because the 4 has a square root of 2 attached to it. The 1 does not have a square root of 2 attached to it. So we need to keep them just separate in our answer. So it would look like 1, then plus minus 4 root 2. So just a heads up, we do technically have two answers for this in radical form. Radical form can be very, very ugly, but it is technically exact. When we do decimal form, it actually, some decimals can go on forever. So that's why we do radical form. But anyway, I digress. Going back, your two answers are technically 1 plus 4 root 2 and 1 minus 4 root 2. Again, two answers. Letter F. Now, step 1 will apply here. We don't have parentheses squared by itself yet. We have that 3 out in front. So we do need to divide both sides by 3. So step 1 is done. Now we want to square root to get rid of the exponent. You, on the left, just drop down your z plus 3. On your right, square root of 4, well, that's easy, 2. And don't forget your what? Don't forget your plus minus. Now, in this guy, not done yet, still got to subtract 3. So be careful here. Let's see what happens. This is a little different than letter E. So z is, and remember, we got to get two answers here. So if we have this, say, negative 3 plus minus 2, how do we get two answers out of that? We do not leave it like this. All right? In in the previous problem, you could keep it like this and not do any adding or subtracting because of the radical. But in my new problem, I don't have a radical. So this means that I will actually physically add and subtract. So to get one of my answers, we need to do -3 plus 2. And we also need to do -3 minus 2. So there are your two answers. Sometimes your two answers are distinct. So your two answers here, -5 and -1. Okay, let's get some more practice. Letter G, what do we need to do first is, I got to talk faster here because of my time. You'll just have to pause, rewind if you need to. How do we get rid of the 1/5 that's out in front of the parentheses squared? Well, we would multiply by 5. So you can get rid of that. Then we have parentheses x squared, so we want to square root both sides to get rid of the exponent. So drop down z plus 3. Square root of 35 actually does not have a perfect square that goes into it. So just bring down plus minus square root of 35. And then our last step, we need to subtract 3. Now we cannot physically subtract it from square root of 35. They're not like terms. So we have to write it in that ugly way. So there's my two answers. -3 plus root 35, -3 minus the root 35. All right, letter H actually goes back to the beginning. We got another easy one. Kind of wish whoever made these packets up would have gone from easiest to hardest, but they didn't. So anyway, we need to get x squared by itself. So the first thing you should do is add 75. Then you should divide both sides by 3 to get x squared equals 25. And now you can square root to get rid of the exponent. So we'll have x squared equals, make sure to throw in your plus minus in the beginning, and then square root of 25 is 5. So 5 and -5 are your answers. Okay, next one. Let's work on getting the parentheses squared by itself. We got to get rid of two things first. First, we got to add 20. And by the way, please don't distribute that 5. That's not in any of our procedure today. You can't distribute, you cannot distribute through parentheses when the parentheses has a squared with it. That's a gigantic rule that not a lot of people know. I'll repeat it again. You cannot distribute with parentheses when the parentheses has an exponent. So what do we do next? We need to divide by 5. Next, finally, we have parentheses squared. So we need to take the square root of both sides. So we can get rid of the exponent and actually get rid of the parentheses. Then the square root of 12, we worked this out earlier. It's square root of 4 times 3, and it's 2 root 3. Let me just write it out so you're not confused. All right, so it came from that. Square root of 4 gets the 2. And, oh, I almost forgot a plus minus. Every problem. And then finally, add 4. And we write it ugly. 4 plus minus 2 root 3. Again, I technically do have two answers in there. All right, we got a few more. And you know what? Time constraints. Going to cut those out. And you do number 1 right now. Pause it and try it. Okay, so the first thing you should have done was divided both sides by 3 to get x squared by itself. So that would be x squared equals 27. And then divide, get rid of the exponent, not divide, square root both sides. So x equals, you need a plus minus. And the square root of 27 should be square root of 9 times square root of 3. And then the square root of 9 is 3. Bring down the square root of 3. So you have two answers, 3 root 3, negative 3 root 3. Number 2, try this one out on your own. Okay, first thing you should have done was add 8 to the 12. Then divided by 5. Then square rooted. All right, so we got x squared by itself, square root both sides. X equals, got to throw in your plus minus, and square root of 4 is 2. Your two answers are 2 and negative 2. And then finally 3. Try this one out on your own. Good luck. First step, add 2 to 106. I hope you didn't distribute here. I hope your second move was divide by 6. Remember, we're getting parentheses squared by itself. That would be 18. Then you square root. Nowhere did we distribute today. So square rooting, we'll get rid of the exponent and the parentheses. Square root of 18 is square root of 9 times square root of 2. Square root of 9 is 3. Bring down the root 2. And we also need the special plus minus. Without it, you're only writing one answer. We need two answers. So you're literally missing 50%. All right, then add 1. We cannot physically add it to the 3 because it's attached to a root 2, not like terms. So we need to write it real ugly. 1 plus minus 3 root 2. And that's it for my lesson. Again, you may want to watch this back a second time if the first time didn't click.